are on our final U, which has to do with Unit 4 and systems of equations, and we have learned so much. We're going to finish this off with word problems, and again, you get to use any method that you would like, keeping in mind that some work better for some situations than others. So let's jump right in. We've got the owner of a new restaurant is designing the floor plan, and he's deciding between two different seating arrangements. The first plan consists of 20 tables and 10 booths, which will seat a total of 140 people. The second plan consists of 21 tables and 11 booths, which will seat a total of 152 people. How many people can be seated at each type of table? So first off, let's go ahead and separate what we have. We know we have tables and booths, so I'm going to make my variables T for tables and B for booths. What we also know is that on the first plan, he's got 20 tables, so 20 multiplied by T, plus 10 booths, and that will seat a total of 140 people. And then we've got, for the second plan, we've got 21 tables and 11 booths, and that will hold a total of 152 people. And the question asks, every table can seat how many people? So when you look at these T's and these B's right here, we are talking about tables and booths, but we have to keep in mind what they're asking us. All right, so for T, we're looking for how many people can sit at a table, how many people can sit at a booth. So notice that these are in standard form. So I'm not going to pick substitution because it would just take too long. I could, but I'm not going to. So I'm going to use elimination. And I have got 20T plus 10B is equal to 140. And then I've got 21T plus 11B is equal to 152. Now this one, these numbers are going to be pretty big, but that's okay. We can handle it. I think I want to eliminate the B's because it's a lot easier to multiply 10 and 11. So I know that they need to be same coefficient, but opposite signs. Best way that I think to do this would be to multiply the first line by negative 11, multiply the second line by positive 10, and that should give it to me. So negative 11 times 20, well, that would be negative 220t plus, minus 110b is equal to, it's okay, go ahead and break out your calculator if you need to, because in the interest of time, I'm going to break mine out. 14 times 11, that's, no, 140 times 11. I could have kept that and just put the 0 on the end. So that would be negative 1,540. And the second line is 210, because 21 times 10 is 210. And then plus 110b, well, I forgot the t there, equals 1,520. So I'm eliminating the booths, and I'm just going to deal with the tables. Well, negative 220 plus 210 is negative 10t. And negative 1,540 plus 1,520 is negative 20. So I'm going to divide by negative t. I meant to say 10 on both sides of the equation, and t, therefore, is equal to 2. So each table can sit 2 people. Not done, though, because I need to know about the booths. So I'm going to come back to my original equations and substitute the number that can sit at the table. So I think I'll use the first plan. So 20 times the number of people that can sit at a table times plus 10 times the number of people that can sit at a booth is equal to 140. I'm going to substitute 20 times 2 plus 10b is equal to 140. 20 times 2 is 40, plus 10b is equal to 140. I want b alone, so I'm going to have to subtract that 40 there. 10b equals 100. Divide by 10 on both sides of the equation, therefore b is equal to 10. So each booth could hold 10 people. Now again, we always want to check, so I'm going to use the second equation, or this one actually up here, to check and see if my math is correct. So 21t plus 11b equals 152. So 21 tables times 2 people at each table plus 11 times 10 people at each table. We want to see if that's 52 people. 21 times 2 is 42, plus 11 times 10 is 110. 42 plus 110 is 152. So therefore we are correct. So every table can seat 2 people and every booth can sit 10 people. All right, let's see if we can find one where we have to do a different type of setup. All right, on this one we have Tara went to play miniature golf on Monday, and it costs $11 to rent the club and ball, plus $6 per game. Grayson went Thursday, paying $1 per game, plus rental fees of $16. By coincidence, they played the same number of games for the same total cost. How much did each one spend? How many games did each one play? So let's go to Tara. We know that she paid $11, whether she played a game or not. So let's let her total cost equal the $6 per game plus the $11 to rent the hall or the club. And then on Thursday, Grayson, he pays $1 per game plus the $16 he had to pay to rent. And we see that we have 2 slope-intercept forms, so we can set them equal to each other. So I have 6g plus 11 is equal to 1g plus 16. Subtract 1g from both sides of the equation, and I am left with 5g plus 11 is equal to 16. Subtract 16 from both sides of the equation. I really meant to subtract 11. 5g is equal to 5. Therefore, g is equal to 1. And I got that by dividing both sides by 5. And I'm running out of room. That's why I didn't show that. So now that I know g, I can go ahead and put this information in either Tara's equation or Grayson's equation. So I'm going to use Tara. That's y is equal to 6 multiplied by 1 plus 11. So let's see, Tara is 6g plus 11. So y is equal to 6 plus 11. So y is equal to 17. Well, let's check Grayson. Might as well. So Grayson is y is equal to 1g plus 16. So y is equal to 1 times 1 plus 16. Y is equal to 17. Okay. So remember, y is the total amount that they paid. So make sure you put that in the right place. They both paid $17 and they both played 1 game. All right. I think that's enough for this evening. If you have any questions at all, please don't hesitate to ask. I'll see you soon.